it's recording. Oh my gosh, this is sick. So I couldn't get an audience this time, but maybe next time. But I was like, we can still do it. So let's do it. I don't know how the framing will look. I have to think about it. But welcome to the first ever Contextualised course. It was on the Jumper YouTube channel, I think. It might be on the second one called Computer Scientist. But essentially, this was sort of like a crazy idea. Didn't think it could happen. Put it forward to a few people, and they were like, yo, you could totally do that. So we're doing it. How's it look? Oh, it's way too small. This is fantastic. Maybe I can zoom in later. Alright, so essentially what I wanted to do today is, what year am I? It's like 16 to 18-year-olds in the UK have what they call like level 3s, so like their A levels. And they do two maths ones for some reason. So they have regular maths, and they have what they call further maths, which I think is hilarious. It's literally called like more maths as a course. So you can do a maths course and a more maths course, which is a thing. And lots of people do the maths one, but less people do the further maths one. There's actually some super interesting details in here that basically I wanted to explore a bit today. Because I think even if you don't do further maths, you're not going to get a qualification and you just do A-level math. If you're doing any like degree after this in the UK that involves some of these ideas, I feel like it's really worthwhile to know about them. So let's explore them. I was going to draw like a diagram of the different things. I really like audience participation. There's no one here. Sorry, I need to live stream is what I needed to do. But essentially, you can have like, in terms of maths course, you can put it as, oh, I need to project my voice forwards. We'll find out in recording. So we've got problem solving here. And we've got like knowledge, what I like to call it here. And essentially from this course that I'm on at the moment, like done by like Bristol, Warwick, Oxford, Manchester University and whatnot, they're saying they want people to be here in terms of the problem solving knowledge aspect. A-level, AS Maths puts them about here, A-level about here, and then AS Further Maths about here, and then A-level Maths here. So what this means is, A-level Further Maths, sorry, so what that means is if you do an A-level Maths, you've got quite a distance to go. So even though you might not get a qualification in these, it's quite useful to grab some of the ideas. So we're going to be grabbing some of those ideas today, by essentially looking at what a mathematical object is, and why it might be useful to know about more than just the standard ones. I'll leave it there. Okay, well. I don't know how well I'm projecting my voice. We'll have to find out. This is super sick. Yo, I'm living for it. It's funny with my my Jumper YouTube channel. It's like views were kind of like, yeah, they're okay. But then I did these kind of videos. It's like dropped. But hopefully I can get my skills back up and go at that as a plan. No one cares. Let's move on. All right. So that idea's down. I might just rub it out. You get the idea. There's a gap, and you kind of need some of the further math stuff. So we're going to get some of the further math stuff. Let's go. All right. Yep. Yo, this doesn't rub out so quick. I can edit this as well. I might not. I might just dump it raw on YouTube, to be honest. So we're going to be looking at fundamental math objects. Okay, let's go. So the most fundamental object most people are aware of. What do I mean by object? So essentially, what is maths? That's probably what we should start with. We're going really fundamental here, by the way. So what is maths? I sort of had to look into the word origin, and it basically is just learnable philosophy, where philosophy is literally just the study of knowledge. So it's essentially the areas of knowledge that are learnable. Because a lot of philosophy is like, just have big ideas, like, oh my goodness, does the world even exist? Whereas in maths we try and turn some of those ideas into literal things you can work with. So instead of just being like, oh, maybe quantity is important, we just created the number line, so these are 1, 2. So instead of sort of thinking about the idea, is quantity important, we literally teach a system where we can look at quantity itself. It's kind of what mathematics is all about, really. So it's very fundamental, and that's why it can be pretty tricky to communicate and to learn about. But we're going to give it a bash. I'm already deep end in terms of abstract and deep. Where did? Yum. Okay, so that's maths. Very cool. Let's dump a what is on there. Covered. Give it a tick. So, mathematical objects. So, mathematical objects are really the building stone of mathematics, because essentially with maths, we're doing philosophy, we need things to work with that aren't just weird abstract ideas, we need concrete things. And objects really help to ground our ideas into things that we can actually work with, rather than just me talking about crazy ideas that don't mean anything. The most like straightforward object that people usually think about is like numbers. So 4, 5, 6, pi, e, etc. And so much so that some people would even define maths as the study of numbers, which it kind of isn't. It's learnable philosophy, but numbers are just such an important part of maths because they're an object that's really easy to see what's going on really quickly. For example, if you have 5 things, it's very clear to see why you might have 5 to describe that. You could also have different things, but they could have the same number. You could describe this as having the same cardinality, and we use a number to describe cardinality 5. So that's the integers, or the naturals, sorry, which is all positive integers. People are happy with numbers though, I don't need to go into numbers too much. But some of the other fundamentals are kind of crazy because we sort of think about them as being separate to numbers or a different thing, or not really part of maths, but like my proposition here is that they all sit on the same level of like completely fundamental. So we've got numbers there. And the other 3 objects I want to look at. Complex numbers are kind of a subset of numbers. Well, they're not kind of. In fact, numbers are a subset of complex numbers. This is going to be fun. Complex numbers are cool if you've never seen them before. And lots of people haven't. That's the thing. Oh, why did you leave this diagram? This diagram's cool. Yeah. Problem solving. What's up here? Knowledge. Yeah. Turns out this diagram's useful. So yeah. So unless you do further maths, AS or A level, or you listen to a crazy guy doing this kind of stuff, you never see some of these objects that are really cool. Complex numbers are one of the objects, but like you seriously need it. If you're going to do any sort of STEM subject degree, and you're only doing A-level maths, you really need complex numbers. So complex numbers, they're not a part of numbers. Numbers are a part of them, which is like the heck. It's pretty sick. When we talk about numbers, we usually talk about real numbers. And what we mean by it is not just that they're real, but it's a very specific type of number. Complex numbers are a more general form. So all real numbers are complex numbers, but you can get some complex numbers that aren't real numbers. So for example, 5, or as you could write in the this pen's running out. Write in the complex number world. You could write it as 5 plus 0i, or it's just 5, they're literally the same thing. You can use an equal sign to say they're literally the same thing. 5 is a real number, but if we have, say, 7 plus 8i, well now it's a number, it's a complex number, but like this thing, what the heck is going on here? Well actually it's the square root of -1, crazy things are happening. But the point is that all real numbers are complex numbers. You can just do 0 times the square root of -1 and everything stays happy. But then when you start bringing in the square root of -1, fun stuff happens. And you end up with a more fundamental form of numbers, really, which a lot of people don't agree with. They like to say complex numbers aren't real, they don't exist, but many mathematicians will defend them for various reasons. I will. And we can look at that more in future videos. I've got 3 minutes left, let's go. Alright, this is a pretty good introductory session, actually. Oh, I love this stuff. Okay, so we've looked at complex numbers. That's the first pillar, so I'm proposing for mathematics. I feel like I had 4 things before. I guess only 3 things. Yeah, okay, 3 things. We've got graphs and we've got linear algebra. You may have heard of some of these, you may have not. Graph is not what you think. When people think about graphs, they think of statistical graphs, which is fair enough, they use a lot. So in maths we have graphs, we also have graphs. So this we sort of call a function, or a statistical graph as I like to call it, whereas graphs, in terms of graph theory, in terms of decision maths, some people call it discrete maths, it's where you have nodes and you collect them with relations. It's pretty wild. So this is what we'd sort of call a graph in terms of fundamental mathematics. It does not look useful at all, but turns out it is. I've got a few videos on graphs. I really like graphs. Maybe look at them a bit more in the future. Alright. And now let's look at linear algebra, which isn't really a fundamental object. That's the name of the study of that fundamental object. The fundamental object is matrix numbers. And matrix numbers are fantastic. If you've not heard about them before, then you should. You've probably used them. Anytime you use a vector, that's a matrix number. So for example, the vector 3, 2 is a 2 by 1 matrix number. And when you have either one row or one column, so for example, some people write vectors like this is a perfectly valid way. It's less common that you can do it. If you've got one row or you've got one column, it's a vector and the matrix number behaves sort of how you want it to. In terms of vectors, and people are happy with vectors, you can add them, multiply it by like a scale of 6 to get like 18, 12 as a vector. You can add them, so for example 5, 4 plus 2, 3, it just adds how you sort of feel it would. So the 5 and the 2 add to make 7, 4 and the 3 add to make 7. So you get vector 7, 7 there. But you can do a lot more with matrix numbers in terms you can expand and do crazy things like this. So I'm running out of space rapidly, this is fantastic. There we go. What we can do is we can have like 3, 4, 7, pi, 2, 0. Oh my gosh, what the heck is happening? That's not a thing of mathematics, but it actually is. This is a matrix number that's not a vector, which I had to call like a non-vector matrix number. Reason being, it's a 2 by 3 matrix number. And for it to be a vector, it has to have one row or one column. But here, it's not got one row, it's not got one column, it's got more rows and columns than one. So we have a matrix number. It behaves a bit differently. And the way you can sort of visualize what the heck is going on here is you can think about it as a list of a list is really the way to think about it. So you can either think about it as a list of two lists, the first list being 3, 4, 7, second list being pi, 2, 0. Or you can actually think about it this way. So you can think about it as three lists. First list 3 pi, second list 4 and 2, third list 0 and 7. And the sort of the tension between is it lists going that way or is it lists going that way is what really gives matrix numbers its like finesse and ability to be sick. Matrix numbers are cool. All of this stuff's cool. And essentially my point here is numbers are an important part of maths, but so are graphs and so are matrix numbers. And together you can get a more rich and full flavour of what the heck's going on with mathematics, and if you only stick to numbers. But numbers are important. It's just there's other things too. And that's kind of what I wanted to express today, which I think I did decently well. I have a class now, so I need to fly. Bye!